Hey everyone! Today in this video we're going to be talking about momentum. Momentum is one of the most important topics in physics. It doesn't matter if you're studying in a board, but it is really important if you're studying in IGCSEs, A levels, the Cambridge assessment, or the IBDP. It's really important. So, what exactly is momentum? And let's see like a common application. Let's think about it. Why does a truck always hit harder than a tennis ball? Even if both objects are moving at a given velocity, the truck has a much greater mass, so it is much heavier. That's basically where momentum plays in to the factor. Momentum is mass times velocity, and an object like the truck will have a large momentum either because it's very massive and has a lot of mass, or it's moving really quickly. So because the mass is so much like comparatively greater compared to the tennis ball, the truck would have a much greater momentum, therefore it does hit harder. Now we're talking about the quantity of motion. Momentum can be thought of like the quantity of the motion of like a body. It depends on the object's mass and the velocity of the object. For example, if we imagine a truck moving relatively slow and we have a bicycle which is moving really fast, you might expect the bicycle to have a much greater momentum just because it's moving so much faster. But because the truck is such a greater like amount of mass compared to the bicycle, the momentum of the truck may be greater. So the mass is just as important as velocity when we talk about momentum, because obviously momentum equals to mass to velocity. Now let's understand momentum. Momentum is a vector quantity, so this means that it has magnitude and direction. Now let's imagine this. Velocity is speed in a given direction. So if the direction changes, that means the speed necessarily might not change, but the velocity would change because it obviously has direction as a component. So when the direction changes, the momentum also changes because the direction changes. So, and the SI units, if we have mass and velocity, the SI unit for mass is kg, and the velocity is meters per second. So the if you combine it, the momentum unit is kg meters per second. Now we're talking about let's introduce another really important topic in momentum. This is impulse. Whenever an object's in momentum would change, an impulse is being applied. Impulse is represented by the letter J, or it's like a symbol. So we can calculate impulse using force into time, or the change in time. So we have J equals to F into delta T. Delta just means change in. So there's another really important topic for impulse. Impulse is the change in momentum. So J equals to delta P. So this is P is momentum. And this can be mv minus mvu. So mv would be the final velocity and u would be the initial velocity. So we can write this as j equals to delta p again. Yeah. Now we're talking about conservation of momentum. This is one of the most important ideas in the entire topic, and if you're studying in IGCSE, IB, or any like board, this is really important because you're most likely to get a question on this in most exams. The basic idea is quite simple actually. The total momentum before a collision would be the total momentum after a collision. So the total momentum before an interaction is obviously equal to the total momentum after a reaction. So for two objects, we can write it as m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Because m1 can be represented because the mass doesn't change of an object. So m1 could be the mass of one object and m2 could be the mass of the other object. U1 and U2 would just be the initial velocity of these two objects. V1 would be the final velocity and V2 would be the final velocity of the second object. However, this will only work if there are no external forces acting on the body. We need to remember that velocity also has a direction. So if an object is moving to the right, it's going to be positive. So velocity, we take the velocity as positive. But if it's moving to the left, the velocity would be negative. So if we have an object initially, one object's moving to the right and another object's moving to the left, the second object which is moving to the left, the u2 would be in negative. And now let's take an example. A 2 kg trolley would be moving to the right at a velocity of 6 meters per second. The right, so let's take this carefully, 6 meters per second to the right, that'll be plus 6. So be careful of the direction, guys. It collides with the 3 kg trolley that is initially at rest. After the collision, the 2 kg trolley would move at 1.5 meters per second to the right. Find the velocity of the 3 kg trolley after the collision. So again, we can say m1u1 plus m2u2 equals to m1v1 plus m2v2. So the trolley, which is 2 kgs, would be m1 and it's moving to the right, so into plus 6 meters per second. And then for the second one, it's going to be a 3 kg trolley, which is at rest. So at rest would be it's at zero, it's moving at 0 meters per second. Then the 2 kg trolley after the collision moved 1.5 meters per second to the right. That just means it's positive again, and the mass of the 3 kg trolley will not change. So we have to find v2. Now with simple algebra, we can substitute v2 as x. So it will be 12 plus 0 equals to 3 plus 3x. So 3v2 equals to 12. v2 or x would be plus 4 meters per second. Plus would mean it's going to the right. Therefore, the velocity would be 4 meters per second to the right, as the positive would indicate that the trolley is moving to the right again. Okay, so that's how we use the conservation of momentum to solve a collision problem. I hope you enjoyed today's video. Thank you.